Hi, my name's Alex Walford. I'm a systems engineer for Confluent, and in this short video I want to show you how you can take a data set that describes something. I can make a predictive model, and then I can put that predictive model in a Kafka Streams pipeline. Now, I've chosen to use the Iris dataset here, which is a very famous, it's like the hello world of machine learning. This has petal and sepal, lengths and widths, and those are used to determine the species of the plant. So in this case, there are three species, Setosa, versicolor, and virginica, and this is like a 3D plot. I wasn't able to plot all four things in 3 dimensions, but look, the goal is to try and separate these things by some kind of plane, and you know, there are different types of models that can help us do this. So in this case, I chose to use H2O, which I think is a really amazing technology. So what I would have done in the past, I would have used something like scikit-learn, and I would have selected the model based on this kind of tree, and then when it came down to creating the model, I would have had to fiddle around with the hyperparameters, trying to find the sweet spot for this model. Now H2O has done all that heavy lifting for us. They have something called AutoML, which is just going to randomly generate a bunch of machine learning models and score them, right? So in this case, look, we've imported the data set and we've split the data into train and test. You've always got to do that to avoid overfitting. And then we've split the data set out, so there's the y as a function of all that the x's. So x are covariates and y is the thing that we're trying to predict. And then look, we have a leaderboard here. So we train these models, and as the models train, they create, some of them perform better than others, and they end up in a leaderboard. And you can specify the number of models you want to try. You could leave this running for ages if you wanted. And once you have a model, once you've left it running for a while, you can select the best model and you can deploy that into a Kafka Streams pipeline. So look, here's our leaderboard. Here's the model that worked best. And look, we can take the leader and we can export it as a mojo. That's a file it's a zip file that contains the model and everything it's going to need, and we can put that inside a Kafka Streams job. So let me pop over to IntelliJ right now, and this is my Kafka Streams job. I have a constructor here that is going to take this model and it's going to pull it from the resources folder right here. So in my Java project, this is managed by Maven. I have a folder called resources. I put the model in there, and the initializer for this class is going to load that model. So that's what these lines are doing. It's loading that model into something that I can use to evaluate new records. So this is the sort of guts of running the Kafka Streams job. I have, application ID that's akin to a consumer group. So if you wanted to scale out lots of instances, maybe have Kubernetes or something like that, you can scale this out up to the number of partitions if you want to get a lot of parallelization. So look, here we go. We have a stream of records coming in, and I wrote a little Java Spring app that's going to randomly select records from the Iris data set, and I can kick that off, and we can see these records coming in. So look here, this is what it looks like. We have the 4 numerical attributes and the outcome, the thing that the species of the flower right here. And so what that's going to do, it's going to take this K stream, this is going to take a stream of data from the Iris data set, and this map function is a bit like a for each on a stream. We are going to take the value from this and call this classify function. Now this classify function, look, we pop down here, it takes a string. This is a JSON formatted string. It's going to use JAX JSON to sort of map this into an object. This is necessary for H2O. You need it a row data. This is like a bunch of like key value pairs that contain the attributes. And once you've created that object, then you can pass it to this model wrapper. So look, here we have a predict function. Predict what species it is based on this row, and then enrich this record, add this predicted species to the row, and output it as JSON. So that's what's happening here. It's you know, maybe 100 lines all together, and I think this is running. So if we pop over to the console consumer here, we can see the outcome. Whoa, okay, so let me grab this, log in to my Kafka node, and we'll see the results. So look, what you can see here is we've gotten these four inputs, and what it actually was, which we wouldn't have in real life, right? We wouldn't know what it was as the data streaming through, and we are predicting the outcome. So it was Virginica, and we predicted Virginica. So as we go through this, we can see that it's working pretty well. Every now and again, it will make a mistake, and the reason it will make a mistake is because look, there's a bunch of overlapping data points in here, so it's kind of hard to separate them. But yeah, let's keep an eye on it, see if it makes a mistake. Usually it's Virginica and Versicolor that get confused because those two overlap. I haven't seen one yet. Okay, all right, I gave it a chance to make a mistake. This is working perfectly. So what we did here, we took a data set, we trained a machine learning model, and we took that model and we put it inside a Kafka Streams pipeline. And it's very simple, fairly simple to do. And I think lots of businesses have use cases like this. I'm thinking of things like if you're a call center and you need to prioritize how to handle a call. Maybe you've got a customer that might churn based on some sequence of events that might have happened to them. Those events could be streamed. You get the call, and it might help you to react on the fly rather than have a conversation that goes badly. Maybe you give them a special offer or something like that. And there are gazillion use cases like this. Every business is going to be unique, but that's the gist of it. How can I create a machine learning model and deploy that in Kafka Streams so it can be used for real-time business decision making? So I hope that was interesting. Thanks so much for watching.